Welcome back to the channel. Today we're going to be focusing on task 12 of the OWASP top 10 series. Now this is going to be XML external entities, or XML attacks if you'd like to call it that. XML internal, let's take a look at the write-up here. An XML external entity XXE attack is a vulnerability that abuses features of XML parsers and data. It often allows an attacker to interact with any backend or external systems that the application itself can access, and can allow the attacker to read the file on that system. They can also cause denial of service, DOS attacks, or could use XXE to perform server-side request forgery, so SSFRF attacks, inducing the web application to make requests to other applications. So basically you would be, this isn't a man-in-the-middle attack, but basically you'd be pretending to be certain user and do privilege escalation that way in order to request information. But anyway, let's read what they say. XXE may even enable port scanning and lead to remote code XXE may even enable port scanning and lead to remote code execution. Basically, as I just mentioned before, what that would consist of is accessing a directory you're not supposed to. That directory enables you to upload a RCE, and from there you got them. But anyway, let's go ahead and keep going. There are two types of XXE attacks: in-band and out-of-band, which is OOB-XXE. An in-band XXE attack is one in which the attacker can receive an immediate response to the XXE payload. Out-of-band XXE attacks, also called blind XXE, similar to blind SQL or blind broken authentication, but there's no immediate response from the web application, and the attacker has to reflect the output of their XXE payload to some other file or their own server. It says deploy the machine, attach the task. Let's click complete. Going to move on to task 13, severity 4, XML. I can't fucking talk today. We're going to move on to task 13, severity 4, XML external entity. And take a look at extensible markup language. Before we move on to learn about XXE exploitation, we'll have to understand XML properties. What is XML? XML, extensible markup language, is a markup language that defines a set of rules for encoding documentation, documents in a format that is both human readable and machine readable. It is a markup language used for storing and transporting data. Now, why will we use XML? 1. XML is a platform independent and programming language independent. Thus, it can be used on any system and supports technology change when that happens. 2. The data stored and transported using XML can be changed at any point in time without affecting the data presentation. Number 3, XML allows validation using DTD and schema. This validation ensures that XML document is free from any syntax errors. Number 4, XML simplifies data sharing between various systems because of its platform independent nature. XML data doesn't require any conversion when transferred between different systems. Take a look at the syntax here. Every XML document mostly starts with what is known as XML prologues. We have XML version followed by encoding and UTF-8. Above the line is XML prologue and specifies the version encoding using XML documents. This line is not compulsory to use but is considered good practice in programming, and to put in all of the XML documents. Every XML document must contain a root element. For example, we have the version, as we just mentioned, we have mail, which would probably be the root element here, and then it's to Falcon from XYZ subject and text. So it looked like this would be like an email. In the above, the mail is the root element of the document. To, from, subject, text are all children elements. If the XML document doesn't have any root element, it would be considered wrong or invalid in the XML document. Another thing to remember is that XML is case-sensitive language. If a tag starts like to, then it has to end by closing the syntax or closing the to, and not by something like is greater than capital 2, because that would be a different child, essentially. Notice the capitalization of the T. Like HTML, we can use attributes in XML too. Syntax for having attributes is also very similar to HTML. For example, we have the text category, message you need to learn about, and then the closing of the text. In the above example, category is the attribute named and message is the attribute value. Now we can just answer these questions quickly, and then we'll move on to the practical part. Question 1, full form of XML. It's going to ask us to type in extensible query language, but I don't really want to type that in, so we'll copy it and we'll paste it. Moving on to question number 2, is it compulsory to have XML prologue and XML documents? The answer is no. Question 3, can we validate XML documents against the schema? The answer is yes. Question 4, how can we specify XML version and coding in the document? And that would be, what's the answer? That would be the XML prologue, I believe. Yeah, okay. So moving on to task 14, severity 4, XML external entity, DTD. Now there seems to be a few of them here. Let's just keep going down the list. Alright, before we move on and start learning about XXE, we'll have to understand what is DTD in XML. DTD stands for Document Type Definition. Document Type Definition defines the structure and the legal elements and attributes for an XML document. Let us try to understand this with the help of an example. Say we have a file named note.dtd with the following content: doc type element note, to from heading body, element to PC data. So basically it's sending an email from to PC, element from PC data, and then it includes heading and elements of the body. Now we can use DTD to validate the information of some XML document and make sure that the XML file conforms to the rules of the DTD. So here we have the version, we have the doc type, note system, note.ddd, note, we have the children here, so Falcon, Feast, Hacking, body, from, to, XYZ, and then the end of the note. So now let's understand how DTD validates XML. Here's what all those terms used in note.dtd mean. The doc type note defines the root element, and as I just mentioned before, the rest are the children. So elements to define to element, PC data, blah, blah, blah. I'm not going to repeat this again. How do you define a new element? So we can do that with exclamation element. How do you define a root element? We can do that by doc type note. Alright, so it's not going to be note because note is basically the name of the file or the document. So we'll just do doc type. How do you define a new entity? I believe it's going to be exclamation element again. Okay, it's not. Interesting. How do you define a new entity? That is a good fucking question. Alright, well I suppose it's going to be entity. Alright, moving on. Let's take a look at task 15. XML external entities and XXE payload. Now we'll see some XXE payloads and see how they are working. Number one, the first payload we see is very simple. If you read the previous task properly, then you'll understand this payload very easily. Here we have doc type replacing the entity name of feast. And then we have some information here, user info, first name Falcon, and that's the first name, and then last name, closed last name, user info. As we can see, we are defining an entity called name. There's the entity called name, and assigning it a value of feast. Right, that would be basically the beginning of the document, and then, or if you found this user in the wild and you were going to then use this payload, we're going to replace that with Falcon below, and that essentially is going to hopefully give the same access level and or spit out something. But anyway, number two, we can also use XXE to read some file from the system, but by defining entity and having it use the system keyword. We have XML version here. Doc type is root entity read system file, and here you can input XYZ for file if you'd like. In this case, we're going to read the etc password, and then root and read, and then close the root tag. Here again, we are defining an entity with the name read. The difference is we are setting it to the value system and the path of the file. So here's the path. If we use this payload, then a website vulnerable to XXE normally would display the contents of the etc password. In a similar manner, we can use this kind of payload to read other files, but a lot of times you could fail to read files in this manner. Try the payload mentioned in the description of the website. So let's go and take this payload here. Hopefully we don't have to create like a note. So the application's back up 10.10.194.17. So let's go ahead and go to that. Perfect. We don't have to create any payloads. I mean, not that it's hard or anything, but it's probably beyond the scope of today's lab. But anyway, we will take the payload here, the version, and I believe we're just going to cat the contents of the etc password. So let's copy this. And it's not going to let us copy due to the fact that the machine is in another tab and it's really not friendly to that. So hold on. It's not going to let us copy paste there, so we can go ahead and type the payload in. Really not an issue. We'll just launch our notes. And we'll define the version of the XML, and then we'll define the elements here. unless I can just copy it. No. Bruh. Alright, so if you're having trouble with copying text from one file to another in this entire application, what you need to do is go here, this little small box, the little arrow, and open the clipboard. Now if you paste in the clipboard, hopefully it's going to allow us to do that. There you go. So if we paste in the clipboard, now we'll be able to copy this, just payload, and then we'll be able to paste it in the web application. Again, we're going to define doc type as root. We're going to define the entity as read, and we're going to be reading the system files of the Etsy password here, and then closing the tags here. So submit. And basically, just like we would in command line, we have exposed the contents of the Etsy password. So basically in Linux, if you were running a pen test or anything of that nature, or with what we've done before in the broken authentication lab, it would list users here and then maybe list some directories and or password. So let's go ahead and move on. Try the payload mentioned in the description of the website. Click complete. Let's go to task 16, XML, external entity exploiting. Now let's see some payloads in action. The payload that I'll be using is one we saw in the previous task. Let's see how the website would look if we'll try to use the payload for displaying the name. So this is Burp Suite, I believe, but anyway, that's besides the point. On the left side, we can see it is Burp Suite. On the left side, we can see burp request that was sent in the URL encoded payload, and on the right side, we can see that the payload was able to successfully display the name Falcon Feast here. Now let's try to read the contents of Etsy password. They're doing it in burp again. And as you can see, we've got some files here. Try to display your own using any payload. So essentially, we don't need to do any more work here. We just need to read this file. And so try to display our own name using any payload. We don't really need to do that. See if you can read the Etsy password file. We've already done that. What is the name of the user in Etsy password? Let's find out here. And if we're looking, we got root, data, login, syslog, home Falcon, bin bash. So probably going to be Falcon here. Awesome. Where is Falcon's SSH key located? Here we have SSH run SSHD user bin no login. Home Falcon bin bash is where it's located actually. So we'll go ahead and copy that. Home Falcon bin bash. Just copy to the clipboard just in case the application doesn't want to agree with us, and then we can post it in there. Looks like that is incorrect. It's going to be the run SSHD user sbin no login. Alright, so it's going to be this Falcon X 1000 followed by home Falcon bin bash. Copy that. It does not like the, let's see what it doesn't like. Alright, so we're going to have to run this again. Not an issue. We'll just grab the payload here. And read system file. Here we're going to replace this with the default location in Linux. So in order to do that, we are going to need the other command here, which would be home falcon /ssh or /.ssh, and you can see the .ssh here. And then it would be ID underscore RSA, and we can remove this here. Hopefully this is the correct payload. Yeah, okay, perfect. So begin RSA private key here, and what is the question here? Try the payload, blah, blah, blah. Where is Falcon's SSH key located? The answer is what we just typed in for our payload. So home falcon /.ssh /ID underscore RSA. What are the first 18 characters for Falcon's private key? That would be this right here. Counting to 18, kind of annoying, but whatever. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Alright, looks like that's the end of the lab. In the next series, we're going to be moving on to task 17, broken access control, and the challenges that go along with that. Now, if you liked this video and found it helpful, please like and subscribe, leave some comments. Thank you.